Dear Mr. Chairman, dear ladies and gentlemen, dear professors, I'm an outsider, I am a student. I have retired as an electronic engineer and started a new life, and now I learn about the water balance and the energy balance in the Danube basin. So my slides are basically going back to the very basics. I was surprised when I have first seen the IPCC chart that the global warming is different, the global average, and on the landscape it's a little bit higher. So I was curious, why is that happening? So there should be something important for us, since we are living on the continent, and we have to understand what's going on the continent. Continent in Hungarians means dry land. So the answer is already given. So basically, all the studies from primary school to secondary school to academic level show that the air is warming up from the surface. So let's go back, let's see what's going on the surface. We have to go back to the systems, general systems theory for Ludwig von Bertalanffy, who says if we have a very complex system, let's try to find the subsystems and let's try to understand what's going on. So there is a surface model from a Czech international team led by a Czech group, and it says that the input of the system is basically the solar radiation, and the monthly distribution is shown with this yellow envelope curve. And the three major outputs are long-wave radiation, the heat itself, and the latent heat. So something is very interesting already here. We see that during 30 years, the envelope curve get higher. So first 30 years from, oh, it's very slow, sorry about this. From 61 to 1990, the blue envelope curve is valid, and later on it becomes the yellow one. So what happened? The proportion of these three output energy components is very clear that it becomes critical in the summer. So evaporation, the latent heat, is a dynamic element which is very critical. During the 30 years, however, the incoming energy has increased, and what we see here, the evaporation, the latent heat, is working fine proportionally until the middle of the summer. In the summer, it decreases, and the heat actually takes over. So the problem is here. So there is not enough water for cooling on the continents. So the problem is basically like when you have an expensive car and your cooling system is down. It's better to stop and rethink how to continue. So we have to continue to solve the problem and increase evaporation. Otherwise, heating will be even more intensive. You can see here quite clearly that if we do not cool, then heating will take over. So that's the homework. So my suggestion is a very simple tool. If we just look at the two dynamic components, heat and evaporation here, then the total can be shown on a chart where the ratio of the two can be seen as a working point. So if this working point is at a certain place, then we understand the changes. We can show here absolute numbers, or we can show here relative numbers. So in the Carpathian basins, this is what we see. During 30 years, let's have a look at this box. This is enlarged here. The working point has moved from here to here. More energy is coming in, more was evaporated, and still more heat remains on the ground. So if we understand what's going on, then we forget the saying that let's save the water from evaporation. This is a loss. No, it's not a loss. That's the most important service on the landscape. So if it doesn't work, we are making a suicide for civilizations. So I think this is such a basic message that this indicator can be shown on a map or tables, whatever. If we understand, we have checked the global average of this evaporative fraction, the ratio between evaporation and the net energy, is 80%. Oceans perform better, 82, landscape average is 67. And if we go down and find out what's going on in Hungary or in southern Germany, or even worse, near over the Carpathian Mountains, we have to be aware that we have to quickly do something about that. So that's basically all. Good news is that Sustainable Technology Program is supported by the Academy of Sciences, and we work on with this team on this within the project. But again, not the technology is the solution. The biological, natural cooling process is the solution. So there is something from this research already documented. I call your attention, please cooperate and let's reinstate the natural processes. That's the only solution on the continents. Thank you very much.
And last but not least, Dr. Huszár is coming.